So behind me are two Cisco ISR routers that I need to configure a client to site IPSec VPN tunnel on. Reason for that is because if the SSL VPN server were to become unavailable for any reason, it gives me a backup remote access method into the network. So I thought it would be a good idea to make a video tutorial on it. And before I actually move on to the final production configuration, I thought I would do more of like a sample config for the sake of this video. And that's for obvious reasons, pre-shared keys, usernames, etc. And but it's obviously going to be a working config, and I'll show that towards the end of the video. So with that being said, if you're interested in learning how to set this up, stay tuned and I'll show you how to get it configured. Okay, so let's get to it. Before I open up PuTTY and SSH into the router, just to give you a brief overview of what we're going to be doing first we need to enable AAA for authentication and authorization. Then we need to configure Phase 1. So we need to configure ISACAMP and all those parameters, and then configure Phase 2 for the IPSec tunnel. We need to configure an IP pool for so addresses can be dynamically assigned to the client when they connect. We need to configure an ACL for interesting traffic, so the traffic that's going to traverse the tunnel, so traffic that will be encapsulated with additional transport headers versus traffic that's just going to be going over the internet. And then we need to modify the access control list for our NAT configuration, so that way traffic that is destined to traverse the tunnel does not end up being translated by NAT. And then one extra thing, it might be kind of a bonus thing, is since I'm also running Cisco's zone-based firewall on this router, I also need to configure an exception in the firewall to allow all traffic that is originating from the tunnel to pass down into my LAN network. So let's start by opening up PuTTY. And we will SSH into that router. So the management IP is 10.050.2. Okay, let's go into privilege exec mode and then jump right up into global config. Okay, so first step, we'll enable AAA. So the command is AAA new model. And then we'll go AAA authentication login, and then we need to choose a name. So I'll just put user auth, and we will make that local. So it's going to reference the local user database on the router itself. Next is AAA authorization network, and then we get to choose a name for this as well. And I'll put group auth. This will be defined in Phase 1 of the tunnel negotiation. So you'll see in a second here, we're going to create a some parameters that define certain things about the tunnel. So the pre-shared key, DNS, domain, the IP pool, access control list for interesting traffic, etc. And we'll also put local for that as well. Okay, so let's create a username. So I'll just make it real generic. So username will be user. Password will be Cisco. Okay, and let's move on to Phase 1, the configuration of Phase 1 for the tunnel. So crypto ISACAMP policy 1. We'll use triple DES encryption. Authentication will be a pre-shared key, and I'll set the Diffie-Hellman group as 2. Okay, now it's time to create that group I was talking about. So when we put AAA authorization network group auth and then local, this is what it will be referencing. So the command is crypto ISACAMP client configuration group, and we'll choose a name, and the name will be VPN client. That pre-share key I'll set as Cisco 123. Again, just keeping it really generic for this tutorial. DNS, I will use one of my internal DNS servers. And for the domain, I will set that as my Active Directory domain. And then for the pool, I'll create an IP pool named IP pool towards the end of this configuration, but we'll reference it here for now. So the pool will be IP pool, and the ACL to define that interesting traffic will be ACL 102. So when the client connects, it will, once it is negotiating, phase one of this tunnel, part of the process will be assigning an IP address to the virtual interface on the client, which will pull an IP from this IP pool that we'll name IP pool. It's pretty straightforward. Kind of like DHCP. The ACL to define the interesting traffic will be a numbered extended access list, and the number will be 102. So this is stuff that we still need to create, and that'll be towards the end of the configuration. Okay, that's all we need to do there. Okay, now we'll move on to phase 2 of the configuration. So that means we need to create a transform set. So we'll go crypto, IPSec, transform set, and we'll just name it TS. And we will use ESP and then triple DES and ESP, MD5 for the hashing, and HMAC. Okay, so that's that for the creation of the transform set. Let's move on to creating the dynamic map. So we'll just name it DM and give it a sequence number of 10. Here we define that transform set we just created, which was TS. So we'll go set transform set TS, and we'll also add the reverse route command. I don't actually need this here because of the way my network's set up, but essentially what it's going to do is whatever addresses that are defined in this pool here, when the client connects, it will actually add a static route on the router that points to the tunnel endpoint. So the client address, and what you can do with that is you can redistribute that into a routing protocol if you want to, so that way you can kind of pipe that down through your network so your routing is correct. So once you configure that, we're done with the dynamic map, and now we just move on to the crypto map. So remember up here when we were sticking in those AAA commands, so AAA authentication, login, user auth, and then authorization network group auth, where we then define the group as a VPN client, which is right here. We're going to plug all of that into the crypto map. So we'll go crypto map, and we need to give it a name. So I'll just name it client map, client authentication list, and then user auth, crypto map, client map, ISACamp, authorization list, group auth, crypto map, client configuration, address respond, and crypto map, client map, now I'll give it a sequence number of 10 in case I need to add anything in there later. Okay, so crypto map, client map 10, and then IPSec, ISACamp, and here's where we define the dynamic map, which we named DM. Okay, so far we have configured AAA we have configured a username to be able to log into the VPN. So the user with the password Cisco. We configured the group. So the group was VPN group, I think. No, the group was VPN client. And we configured phase 1 and then phase 2. So what's left is we need to apply this crypto map to the interface for our WAN connection. And we need to create that access list to define our interesting traffic. And we also need to modify the access control list for NAT so that way that interesting traffic doesn't end up being translated. So gig 0 is the interface that I'll apply this crypto map. So we'll go crypto map, client map. Now, in most cases, this is all you have to do to define the crypto map on the interface. In my scenario, I'm running HSRP for redundancy on the WAN side of this router. So if I do a do show run interface gig 0, you'll see that I have HSRP enabled here. And that's because there's another upstream router that handles the connection for this provider. So I have another redundant router, so that way this can fail over in the instance where an interface fails, the whole router fails, or if there's like a planned outage for maintenance or something like that. So the standby group is named HA-WAN1. So in my case, I'm going to issue the crypto map, client map, redundancy, and then the name of the HSRP standby group. And then actually, if I had, since I'm SSH'd in, it's not going to show any syslog messages. So let me enable terminal monitor, and then I'll go back into gig 0/0 and show you that once you enable that crypto map, you should get a, so you see that it says ISACamp is off. When you enable it, or when you first issue the command for the crypto map, you'll see a message that ISACamp has been turned on. Okay, so whoops, I keep hitting my microphone. Okay, so we still need to define the IP pool, and then we need to define the access control list for the interesting traffic, and then modify the access list for network address translation. And then, like I said at the beginning, since I'm running zone-based firewall, I need to punch a hole through the firewall to allow the VPN traffic through. So let me start with the IP pool, and the command for that is IP local pool, and then since I defined it as IP pool up here, I need to make sure that I name it IP pool, and then I will just use addresses in the 192.168.20.0/24 range. So we'll start with, I'm sorry, 200.0. So we'll start with 1 and then end at 50. Okay. Now, we'll go access list 102, and since most of my internal network on the LAN is on the, actually all of my internal network on the LAN is in the 10.0 network, I need to define in this access list 102, the interesting traffic is anything in the 10.0 network that would be communicating with the 192.168.20.0 network. So I'll put access list 102 permit IP 10.0.0.0 and then a /16 wildcard mask. So, which is basically the inverse subnet mask. So otherwise, if this wasn't a wildcard mask, if you were using just the subnet mask, it would be 255.255.0.0. which would define the 10 and the 0 as the network. Basically saying anything that's 10.0 will apply here. So anything in the 10.0, I wish I wouldn't have turned on the terminal monitor because I'm just going to see random syslog messages from my firewall coming up here. So access list 102 permit 10 network going to 192.168.200.0/24. So the wildcard mask for that would be 0.0.0.255. Okay, and then our NAT access list. So do show access list 101. This is the access list that is defined in the NAT statement. So what I'll do is, since I have 30 and 40 here, I can squeeze in a deny. So I'll just go IP access list extended 101, and then line 10, deny IP. Pretty much the same thing that we defined in access list 102. So we want this to be defined as our interstring traffic. This will be what is those extra layers of transport headers will be added to as traffic that's defined here. But we don't want it to be translated either, since it's not actually going out to the internet. I mean, it's going out to the internet, but it's being tunneled. So we don't want, basically we don't want anything, in the 10 network to be translated to whatever our NAT configuration says when it's traveling over to the 192.168.200.0 network. So we'll go deny IP 10.0.0.0/16 wildcard mask 192.168.200.0 and /24 wildcard mask. So do show access list 101. Okay, so there's the deny statement for NAT. And before I test this out, I am going to configure an exception in my firewall. So if this doesn't apply to you, you can skip over this part. I'll do my best to add some pointers in the description below, so you can just click on that and then skip to the next timestamp. Okay, so in order to punch a hole through the firewall, I'm going to start with an access list. So I'll go access list. Actually, it's going to be a named extended access list. So IP access list extended. And I'll put FW for firewall, so I'll know if I'm looking through access lists that this one pertains to a firewall rule. And that's normally what I do. If it's an access list for a route map, I'll put RMAP hyphen. Even if it's an ACL that's just being used as an ACL, I'll put ACL hyphen or ACL underscore. So that way I know that this is an ACL that's just being used as an ACL versus this is an ACL that's being used for a route map, or this is an ACL that's being used for, a firewall or what have you. So, or if I was redistributing routes into a routing protocol or something like that. So, so for this, we'll go IP access list extended, FW, and then VPN to LAN. We'll go permit IP 192.168.200.0 /24 wildcard mask to the 10.0 network. Okay, now we need a class map, so I'll go class map type inspect VPN to LAN CMAP, and then match access group name. I'll just copy it in here. Okay, then we need our policy map, so we'll go policy map type inspect, and I'll just go WAN to LAN, since this will be the actual service policy that I'll be applying to the zone pair. So policy map type inspect, WAN to LAN, PMAP, class type inspect, and we want to inspect the class map that we just created, so VPN to LAN CMAP, and we want to inspect that traffic. Inspect. Sorry about the syslog messages that keep popping up randomly. Okay, so now we need to create our zone pair. So we'll go zone pair security, WAN to LAN, source is WAN, destination is LAN. Apply that policy map. So we'll go service policy, type inspect, and then the policy map that we just created. So WAN to LAN PMAP. Okay, so we should be good to go. We can configure the username, the group, the phase 1 and 2, AAA, the IP pool, access control list, modified our NAT access control list. Excuse me, I'm getting the hiccups. And then modified our firewall to allow the traffic through. So I think we're good. So I'm going to move on to my phone. So I'm actually using my phone to record this right now since I don't have a super fancy camera or anything like that. So I'm going to have to take myself off the screen, but I'll do a screen record on my phone to show you the configuration on my phone and that sort of thing. So let's go ahead and do that now. So first things first, I'm going to switch over to LTE so that way I can connect from an external network. Go to General, VPN, add VPN configuration, IPSec, and I'll just name it IPSec tutorial. Server, I already have a DNS record that points to this router right here. So that would be vpn.rmtechcentral.com. The account is that user we created named user, and the password being Cisco. And then remember the group name was VPN client. And the secret was Cisco 123. Okay, and that should do it. So let's select that as the connection and see if we can connect. Okay, we got a login box, so that's good. We'll type in our password of Cisco. Okay, I see the VPN connection on the top. So let's see if I can access something on my LAN. Let's see if I can access my storage server. So since we set the DNS as that internal DNS server, and the domain is my Active Directory domain, this should resolve, and we should be able to access the NAS. And there we go. All right, so it looks like everything is working. So we'll go here to users, public, okay. All right, and that is pretty much it. Just trying to think really quick if there's anything I'm overlooking. Yeah, I don't think so. Sorry if I went a little bit fast for some people. I mean, I guess that's the good thing about it being a video, is the fact that you can go back and you can rewatch it and that sort of thing. I'll do my best to link in the description if I have a moment to, I'll stick in the commands that I used, so that way if some of you just want to lab this up, you can just do a quick copy and paste and then change things to suit your network as needed. But other than that, I think I'm going to wrap it up here. So thanks for watching this video. I hope you learned something. If you have any questions, leave a comment in the comment section below, or you can send me an email to rob@rmtechcentral.com, or you can use the contact form at rmtechcentral.com as well. Like this video if you liked it, thumb it down if you hated it, and I'll see you in the next video. Thanks for watching.